Hello, everybody. Uh, I want to present my presentation, which is entitled "Deep Learning-Based Segmentation Pipeline for Label-Free Phase Contrast Microscopy Images." This is the outline of my presentation, which I will present it. Okay, actually, segmentation is one of the most important and challenging parts of the medical imaging systems, and it has some advantages, especially make the easier the process of the analysis of the cell behaviors, and also the segmentation reduce the workload of the batch analysis for the biologist. So if we have the auto segmentation system, the biologist will have this chance to analyze the batch analysis of the cells. So segmentation can be helpful for the biologist. About the literature review of the cell segmentation, there are vast type of the architecture which tries to increase the performance of the segmentation task, but among all of them, UNet and its variants is very successful in this field, because due to lack of the annotated image in the medical application, UNet is very suitable for this task, and also because UNet has a specific test and its autoencoder architecture, which has the capacity of the to train the method, train the data with low annotated number of the images. But besides of the unit-like architecture and their variants, there are some other methods such as mask arsin and some complicated methods, but they are not most of the time they are not suitable for this task, but they have a good performance in some domain of the medical image applications. Okay, the data set which we use in our study is the invasive breast cancer cells, which has a mesenchymal morphology. We got this data set and start to annotate them with the help of experts, and also this data set has the 600 frames, which we just extract the 45 of that data set and start to annotate them, which we select them with the shape of the data set. We extract them with the shape of the data set. But for the preparation of this dataset, actually, this dataset has four important steps. The first one is to preparation of the cells. These cells are prepared and keep for a specific time to be generated. Afterward, with the help of the microscopes, they are visualized and they keep forward to the verification step. In the verification step, we analyze the attributes of the cells and their features and start to annotate them correctly with the help of the experts. And in the last step, we have the ground truth, which is created with the help of the image, which is application for medical image annotation for our purpose. Okay, the model which I presented in this work, it is the unit-like architecture, but the unit has the plain blocks, and each blocks in the down sampling and up sampling is the plane and convolution. But we start to apply the backbones of ResNet 18 in the encoders of our proposed method. So we start to extract from COM1 to COM5 for our analysis, and start and replace them with the plain encoders of the unit. But besides of that, we also, moreover, we also apply this encoder in the FPN2. In the ResNet 18 FPN, as I explained, we have the bottom-up pathway and also top-down pathway. In the bottom-up pathway, we have the encoder, which is start to extract the features from the train input data. But as I said, we have the encoder parts from COM1 to COM5, and also we excluded dense parts of the ResNet 18 from our architecture and put them in the FPN, and afterward, in the top down, with the help of lateral connection, we concatenate the extract feature, and in the further convolution pass, we have the two convolution pass, and after the T1 block, we have the upsampling step, and at the end, we have the concatenation part, which concatenate the reconstruct parts from the upsampling part, and at the end, we apply the sigmoid and drop out to reconstruct the original image, but it's binary segmentation from our input image. That's the first method which we presented. For the second method, actually, we start to reconstruct the unit with the ResNet 18 backbone, but we also replace the residual block in the decoder parts. For the encoder parts, as I explained, we have a five convolution, five conv from conv1 to conv5, and afterward at the bottom and in the lowest level resolution of the lowest resolution, we have the bottleneck, and afterward we have the upsampling step for to retrieving the extracted feature, and at the end we um, we employ the we employ the original input size from in the decoder path. So in each block, we apply the ResNet 18 blocks, and but all of this, but this architecture has the pre-trained weights of the ImageNet. So our weight initialization has the ImageNet weights. For the training methodology, actually, as I explained, we have the encoder of the ResNet 18, which has the ImageNet weight. But afterward, we also apply test time augmentation. Test time augmentation in the prediction step, which is important in increment of the results. And we put that result in our experimental result. And for the loss function, moreover, we apply the combination loss types. We sum up the binary cross entropy besides of the dice loss, which was more successful in our experimental result, because dice loss is more powerful in extraction of the boundary regions. So adding up this loss to the binary cross entropy loss has a good better result in compare of the other loss types. For evaluation metrics, we apply the well-known evaluation metrics such as the precision, recall, Jacquard, or intersection over union, dice loss, dice coefficient for our evaluation metrics part. Actually, this is the experimental result or quantify results of the MDMB. As you see, our proposed method, ResNet 18 unit and ResNet FPN, which is the feature pyramid network, which at the ResNet 18 to encoder of that is better in comparison of the baseline method, and also and also in compare of the unit. As you see, EGT fun test is very low in the results of in our results, especially in the IOU. But in compare of the unit and in the unit, our method ResNet 18 unit and ResNet 18 FPN has increment in all of the applied evaluation metrics in the intersection, over union, dice loss, and precision and recall. So in the next slide, as you see, we applied the we show the represent the qualitative results of the methods. As you see, the purple part is the false negative parts, and is the green part is false positive part. As you see, the amount of false positive and negative in the ResNet 18 FPN and ResNet 18 unit is less than in compare of the other methods. And also, especially in the separating regions or overlapping regions, our method has better performance in compare of the baseline and the state of the art methods, or especially in the unit. uh, we have the improvement in quantitative and qualitative sides. As a conclusion, actually, we can reach this result that applying alternative encoder ResNet 18 in our method has an improvement from the quantitative and qualitative sides. And also, applying the pre-trained ImageNet on our application can help to have a better result in compare of the with other type of the weight initialization. And also, this modification will be helpful in the reduce of the disparity in the coder features of the methods, which little unit has a low performance in compare of our proposed method. For the future work, actually, we want to deploy the instance segmentation task for our result for the tracking purpose. And also, we may apply the alternative encoder to gain a better result, such as EfficientNet and other methods. And we will evaluate the performance of different our result in the different modality, and also extract the time series data set by construction of the lineage relationship among the sets. That's all of my presentation. Is there any question? I'm ready to answer it.